Welcome to the SPSS tutorial video on categorical variables and regression. In this video, we'll be using an altruism dataset in which I've created several codes, dummy codes and contrast codes, based on categorical variables. You'll see in this dataset that we have a variable of location, which, when I select the values, shows you that people in this study live either in a city, town, or rural area with the codes of 1, 2, and 3 respectively. In addition, we have measures for altruism, socioeconomic status, and neuroticism. The bottom 5 measures here I created specifically for this dataset. I started this dataset with only the first 4 measures, and each of the bottom 5 measures I created using a recode from the location variable. You'll see that our variable named city, its values are coded such that individuals who live in a city get a category of 1, and anyone else, so those who live in rural or in town, get a code of 0. In addition, I set up 2 contrast codes, which should be discussed by your class instructor, in which I compare city to others, so city would get a positive 1, and those in the others, so either town or rural, would get a negative 1, and a second contrast code to compare town and rural. Remember that you need G-1 codes to completely code a categorical variable. In this case, we have 3 levels of location, so G is equal to 3. To completely code, whether using contrast or dummy codes, the 3-level variable of location, we need 2 codes. Here we have 2 contrast codes. Alternatively, we could use 2 dummy codes. So let's look at each of these code variables in predicting altruism first. We'll go to regression under Analyze, Regression, and Linear. Our dependent variable will be altruism. Now in regression, because it treats each predictor as a linear variable, we could not move the location variable into the predictor. Why? Because city, town, and rural are coded continuously, but they're not actually a continuous variable. They're simply different categories. Instead, we could create, for example, our contrast code set as a set of predictors. We can look at the output after clicking OK, and moving down to the overall model summary, to the R-square of how well is this overall model, our contrast codes of location, predicting altruism. We get a significance test, an F-test for the overall model. We also get individual parameters. Is there a statistical difference between city and others, represented by the first contrast code? Is there a statistical difference between town and rural? By that I mean, is there a difference in altruism between those who live in town and rural? In this case, both are statistically significant. You might ask why we would use regression instead of ANOVA to be conducting these analyses. Well, in regression, we can add additional predictors. For example, from the Analyze, Regression, and Linear, this time we'll use the dummy codes instead of the contrast codes, for no reason, but just to illustrate that we can use different types of codes. I might use my 2 dummy codes, as well as predictors of SES and neuroticism. In this case, we have a 4-predictor regression model. 2 of the predictors, dummy code 1 and dummy code 2, represent the codings of the categorical variable location. Our next 2 predictors represent completely different but continuous variables. When we click OK, we see that our model now, when we look at the individual coefficients, includes all 4 predictors. We can see that both of our dummy codes are statistically significant, and so are both of our predictors of SES and neuroticism. In this case, we benefit by using regression over ANOVA by adding continuous and categorical predictors into the same model. In future videos, we'll be examining interactions between these. And if you have any questions about how to recode variables, how to go from the location variable into the dummy or the contrast codes, be sure to watch the video on manipulating variables, specifically for the section on recoding.